Yeah. Well, welcome everyone. I'm recording it for future purposes and so that other people can see it. Good morning and good night and good evening and yeah, a variety of people from the whole world. So today's training, like I said already earlier, is going to be about off-grid and backup systems. So basically anything non-ESS. So you could even say that marine system is sort of more or less an off-grid system. It's all systems that do not have a lot of AC available or only specific, mainly generators. And then backup because it sort of belongs to the off-grid scenario. Next week, we talk about ESS. So all ESS questions, please wait till next week because otherwise it gets a bit muddled. And that's a tricky topic by itself already anyway. So please keep ESS with ESS. Well, here we go. I'll start my screen share. Yep, share. It's getting smoother and now start presentation. And that change this view as well. Yeah. Oh, yeah, good. So this is off-grid and backup systems. Well, what I'm talking, like I said today already, DC only solar system, so just with DC. Then we add the inverter to a system. Then we call inverter charger. Then we add AC, but yeah, we have already DC solar. We potentially add AC solar in with that, so grid feed inverters. Then I'll talk about systems with managed batteries. So that's a bit sort of special notes here and there. Then backup systems, and then large off-grid systems, and then yeah, training and more information. The photo on the side is from My Energy SA, so most of give credit where credit is due. It's a really big system in the outback, and yeah, well, the system is of course in the building, but you see the solar panels. But that's basically off-grid, so that's what we're talking about. Well, first we start smaller, so DC solar only. So that's actually a lot of these systems actually have this. So this is DC solar. So you've got solar panels, you've got DC loads, you've got a battery. Otherwise, there's no point. Otherwise, when the sun is not shining at night, you need a battery to charge. I mean, to keep energy for during the night. Usually, these are fully autonomous, so you can get yeah, just a solar panel battery. And yeah, some DC loads could be automatic gate openers, could be security systems, could be water pumping system for livestock. Street lights is one, security camera systems, electronic traffic signs. The stuff you see by the road quite often, you know, where the like merge lanes or COVID messages and stuff like that, they all sit on those electronic signs quite often, completely autonomous. During the day, sunlight, and at night they run off batteries. Very small residential systems, mainly in like underdeveloped countries and or where people don't need any power. So you've also got really people that hardly use power can perhaps go DC as well. And in the old days they did, just with some DC lights, DC fridge. And small DC automotive or marine systems. I just realized that in this whole series I don't include marine and automotive, but that's basically the same as these systems. You can, yeah, a Victron system can go anywhere, being boat or vehicle. But it, maybe there might be some space for later on presentation just on those systems. So the picture on the side again is from one of our distributors. I forgot because I made all this in the last week. I actually forgot where this was. But as you can see, it's DC only, so solar charges. Solar charges are in there, little system cabinet, solar panel, and this is probably some satellite monitoring type thing, or yeah, it looks like some remote telecom thing. But these can all be found on our blog. Blog is a really good spot for ideas of what we do, where, and what our customers do. And if you have a really nice system and you're really proud of it and you think, could that be something for the Victron blog? Yeah, of course. Let your sales manager or your distributor know. And then we get in touch with you. And yeah, we're always looking forward for yeah, end user stories. Yeah, so small system. Yeah, Africa, small solar panel where maybe they have a DC light yeah. Or this here is a security camera somewhere, probably Sweden or Norway, looking at the snow. So these systems quite often don't need AC at all, DC plenty. So you have basically your battery, you connect your DC loads to the battery. Via a solar charger, you connect to a solar panel. Solar charger often has a dedicated output for loads in there, so load output. Load output is actually being monitored, so if the battery runs down, then the switch will open up and turns the loads off. So that's yeah, so that's our smaller solar chargers. The bigger ones don't have a load output. And then if you do want load output functionality, you need to put a device in called battery protect. But we at length have talked about a whole lot of other systems in the past already about what all these parts do. So basically this presentation is how it all comes together in the system. So if you have a bigger solar charger, because you need some more power, one like that, for instance, on this was system is a mobile egg unit. You put it in your neighborhood. It has a lot of chickens. Chickens lay eggs, and then you can buy your own chickens, or you get your eggs dispensed from the egg unit. So I think it was a bit of a prototype system or a fancy system. This was a blog story during Easter. So that's yeah. So that whole shed runs off DC, hence the DC solar chargers in there. Because you use a bigger solar charger, because that whole roof of this shed is full of solar panels, so it's not one or two panels anymore, it's a whole mini array. Then you have a bigger solar charger, and then to disconnect, you use the battery protect, and then when the voltage goes low, it will disconnect the loads, saving your battery. So you don't want to run your battery down, because if you do, then yeah, you have to buy a new battery, and that's expensive. Small system, battery charger. So because this system is probably perfectly okay just by itself, although it did have a battery charger. That's why we used the photo. I think over here there's an IP67 battery charger in there. This person in the boat, he probably has a battery charger somewhere as well, because if he has to motor a lot with this little electric motor, then eventually his battery might get empty. It might be a clouded day. So eventually you want to potentially have an option to charge the batteries. Bad weather, issues with the system, blown fuses, or other weird stuff going on. So it's quite often handy to put a battery charger in, and that battery charger then connects to a generator for an off-grid system. Can also connect to the grid, of course, but in these applications, we connect that to a generator. If you want to see how full or empty the battery gets, you can put a battery monitor in, because especially the guy in the boat, he probably wants to know how long his batteries are going to last while he's traveling in his solar boat. So that's where the battery monitor comes in really handy. You can even have fancy stuff that the battery monitor will start a generator, or that the battery monitor will drive the battery protect. So you can even connect things then again. But yeah. Another application, DC only, is streetlight applications. So you can either use the solar charger with load output. The load output naturally connects to the streetlight lamp, so the light inside the streetlight. And then normally, the normal function of a load output is that it will turn off when the batteries get empty or flat. But in streetlight scenario, you want to drive the lamp only when it's dark. And with an MPPT, we know when it's light or dark, because if there's no sun shining on the solar panel, so the PV input is with 0 volt, then we know it's dark. And there's algorithms for this, so you can actually learn when, because the sunlight changes every day. We have an algorithm in there, and that's commonly known stuff. So we can actually know up front whether it's going to get lighter or darker the next day. And so we're really good at knowing exactly when twilight starts, when dark starts. So you can use this to drive this load output. It still will do its main function, that it will turn off when the batteries are empty, because you would always want to protect the batteries. But on top of that, it will now switch off, switch on at sunset, and then we'll switch off at sunrise again. And that you all set with the Victron Connect app. So Victron Connect app, go into the settings, find street light, and you have to enable it first, and then you get all these settings here. So then you can run also MPPT solar chargers as solar charge, yeah, the solar lighting units. Also could be handy for security cameras. Let's say you only want to monitor your front yard when it's dark to see if there's any burglars or any other people that should not be there. Security lights that go on instead of street lights. Yeah, so there's that's possible in our case. Another way, some street lights have a LED driver attached to them. So the LED driver is there to, it's a PWM driver, so it basically it drives the LED in the street light, but it also, because it's pulse width modulated PWM, it will chop into the DC to save power. So so a lot of street lights have that actually with it. In case that's used, then we have a special cable, the VIA Direct Digital TX cable. So it goes from VIA Direct to the PWM. So from the MPPT to the LED driver, the PWM LED driver. And it will help dim, it will give the signal and stuff like that. So that's also supported. That's called the TX port because it's the TX cable. VIA Direct port can be used in a lot of different scenarios. Yeah, anyway, so you then set the settings with Victron Connect. And then the LED drivers, we recommend the Recom, Glacial Power, 2 types, and the Meanwell. And if there's ones you don't are not supported, but you are going to use a lot, and we need to support them, let your distributor or sales manager know, and then we can look into those things. But I think this is more or less the bulk. I haven't seen emails of late, people trying to connect to ones we don't connect to already. So that's, yeah, kidding. And that's the beauty of Victron. We are so flexible that, yeah, if you ask, we do in a lot of cases. Sometimes it's easy, then we do it straight away. Sometimes it's hard. It gets put onto a wish list. It will be added to a wish list. So that's all possible. So yeah, just DC gets a bit boring, and you can't do everything with it. So eventually you'll have to add AC to it. So first thing is you add an inverter, small system. So you have your solar charger and your inverter in the system. And these are systems, yeah, so you have DC solar, DC loads and AC loads, battery. It can usually fully autonomous, and you might perhaps have a battery charger in there in case you need to do emergency charging because the batteries are bad weather and stuff like that. The market is quite similar: security cameras, small residential system, small automotive or marine systems. Yeah, example, this was after Hurricane Maria, I think it was called, in the Caribbean. There was that really super hurricane that wiped a lot of islands out. So there was a Dutch company that went in and put emergency systems everywhere for people to have at least power until all the grid was reconnected. And so, as you can see, the leaning here on the refrigerator, that's a little board with a system on it, an inverter, solar charger, some basic, yeah, just to run your TV, radio, fridge, lighting. And there's countless systems like this all over the world. There's a lot of people that, yeah, that live with systems just like this, Pacific Islands, but even probably in Australia. On your boat you do, in your motorhome you might. So that's that happens that way. So in a system like this, of course, again, you have the battery. You can put a battery monitor in there if you want to. It's not necessary. If you want to know state of charge, handy. It's like the fuel gauge for the battery, so you know how full or empty the battery is. You have your solar panel with the MPPT solar charger, inverter. Inverter will change from DC to AC. So, and then it will burn AC loads up to the rating of the inverter. If you want to know what's going on and you want to log in, but that's for the scenario of the photo, that's not really the option. But sometimes people, but motorhome might. If you want to know what your inverter is doing, you can connect a Bluetooth dongle to that. We also have a smart battery sense. that looks at battery voltage, but also looks at battery temperature, and that temperature information can be fed back to the solar charger, so you can do temperature adjusted charging. So you can either use a BMV with a temperature sensor or the smart battery sense. Yeah, so there's a lot of different things possible, which I talked at length in all my previous presentations. Then again, battery charger in case you need to top things up, or the possible of a backup generator and or a small little portable generator that you can use in case you have really bad weather or if there's an issue in the system. So that's yeah, really small system with an inverter. One option too, and this I talked, I think, yeah, they're becoming one big blur, all my past ones. I talked a little while ago about, I think we mentioned it, that we have it. It's pay as you go, PG solar home system. So customer types in a code on a little, yeah, this was a predecessor, and that's now all combined into one unit, that box. You type in a code on the box, the code you buy from your local news agent, or you have a phone app or something like that. You generate a code each week, each month, so you can buy power for a little while. And then once it runs out, you have to get a new code. You have to buy money, pay money to get a new code again. Well, anyway, so this is, we've got a special sales manager dedicated for this market. If you need, or if you want to explore that, let your sales manager use, or your distributor or sales managers know, and then we'll get you in touch with the right way. So yeah, so this is really, again, small systems where people don't own the system, they rent a system and they pay money every week, every month to have energy. Small inverter off-grid system. Again, this time we have, we're using the load output of an MPPT, so we have a small MPPT. It runs the DC loads, but we also have an inverter in the system. The inverter cannot be connected straight to this load output because this is only rated at 10 or 15 amps, and a small inverter will take more than that on the DC side, easy. So it can't be connected directly to that load output, but what you can do is connect the positive side of the load output to the H terminal of the inverter charger. And then when the load output is on, it makes that positive output 12 volt. The H terminal inside the inverter sees that there is 12 volt there, and that's a sign to turn on. So that's a nice way of steering your inverter straight off the load output, but not connecting it, only the control from there. You can, of course, put also a battery monitor in. And with the battery monitor has a relay as well. That could potentially turn the inverter on, so you can do it that way. So there's definitely, definitely multiple ways to skin a cat, I think the saying goes. So here again, examples of those type of systems, small inverter. This one's got lithium batteries, that one probably not, because that's somewhere in South America. So that's, what you're looking at, small systems. Well, just an inverter is okay for small loads, but eventually if your loads get bigger, and well, basically from 500 VA onwards, we already sell inverter chargers. And if you combine the two together, and I spoke about it last week as well, you basically get your automatic changeover at the same time. So combining them together, you end up with an inverter charger. So these are bigger systems. The battery bank will be bigger. You will have a generator in the system probably, or actual grid, depending on what type of system you've made. There'll be a bigger MPPT or multiple MPPTs. So because you have a bigger load, this is a 3000 VA unit, you want to have more load. So you need more solar as well if it's totally off grid. So you have bigger MPPTs, and you probably have system and or battery monitoring in there. So you'll have more stuff going on because you want to know not just state of charge of the battery. You want to see what solar input you're getting. You want to see a lot of things. So systems with a multiplus. Multiplus connects to AC on this side. On the other side, it feeds that straight to the AC loads. If AC is not running or the generator is not on, it will take it from the battery, will convert it from DC to AC, and then feeds that in the AC loads. To top the battery up again, you connect solar, and with a bit of luck, you have enough solar that you never need to run the generator, or you run the generator a few hours a day because you don't have enough space and or money, or it's not practical to have so much solar. Could be a really big system. So there is systems that have total solar, the systems that rely on running the generator at least for a few hours a day. The systems that might have grid occasionally and need to do some backup type thing. So it's a really big range out there, what they all have. And of course, you can still have DC loads. Well, maybe should have put that in the drawing, but I sort of was a bit lazy and then copied and paste some drawings we already have. And then control. The MPPT has got a VIA direct connector or VIA CAN, depending on which MPPT you use. The battery monitor has a connector. The inverter charger has got an RJ45 connector, VIA bus connector. All this information goes to a potential monitoring device. That's the color control or the servo or any of the other DX devices. Then you can see your whole system. So on the screen, you have your whole system right there. Because this thing is quite smart, it can also automatically start a generator. So you can say battery empty, color control sees that, start generator, and then will top the battery up a bit until perhaps 80% or something like that. And then wait until the next day to see if sun is coming, and if not, do more. So it can really, really flexible. So this system here, so you've got batteries there. You can see 2 MPPTs being used, and he's got an inverter charger where he's taking the top lid off, which is interesting. No lid means more cooling. Looks like he's in Africa, so it's hot there. So Australia also, they quite often take the lid off. So this is yeah, that sort of system. Systems with quattro AC and DC loads. So if you have 2 sources of AC, so generator and shore power, but it should really have said grid power. Could also be on a boat, by the way. Let's say you have really unreliable mains. It's only occasionally there. You need a backup generator anyway. Then you need a quattro with 2 sources. So you get you get 2 AC inputs with an automatic transfer switch. So it will see whichever is live and connects to that. You can even do programming with that AC input. So you can say, as soon as grid is back, disconnect the generator and connect to grid. You can even put logic like that in. It can run 2 sets of AC loads, or multis can as well. Multis have only 1 AC input, but have still this second AC output. So AC out 2. That switch will be closed as soon as you have grid or generator running. And the reason for that is you might have really big loads in your system, like water heaters or something like that. You never want to run off the battery, or you start welding or something, and you think, yeah, if I start welding, my battery is empty in no time. I turn the generator on, then I weld. So the generator is on, unit sees that, will close the switch, and then AC output 2 is live, and then it goes to your welding device. So this output, so AC1, out 1, is for essential loads, and the other one is for non-essential. So stuff you don't want to run off the battery. So that's a nice way of defining 2 groups of power. Again, if you have DC loads, by all means use a battery protect, because as it says, it protects the battery. The device is a lot cheaper than your battery bank. Putting that in will probably save your battery bank one day, and then you'll be thankful you put one in, because a new battery bank is really expensive. You can run the battery protect individually, autonomously, because it looks at voltage, but you can even steer it if you want from a battery monitor, let's say. Battery monitor's got a relay at the back that can turn things on or off. And then we have here an MPPT with a bigger array. So this system needs more solar than just a single panel quite often. So you can put multiple solar panels together in series, as long as you don't exceed the input voltage. In this case, it's 140 100 volt we all go all the way up to 250 volts DC. Anyway, and bigger in the future as well. Multiple, so you have limits per unit, so you can't go too much per unit. Sometimes people want to split things up because of redundancy, or they want to follow the sun. Let's say it's a house, morning sun on one side, after midday sun on the top, and then afternoon sun on the other side of the property and or the house. You could easily split up the solar charges. Got one customer that builds motorhomes. He does multiple solar charges because those motorhomes, they go to a lot of all over the world. And sometimes in some places they steal solar panels off the roof. Then you have at least a few panels left by the time you wake up and chase the thieves away. You have still two arrays left, hopefully. Yeah, so that's it's possible to double up, and there's no limit to how many you can do. They don't fight each other. They're perfectly okay. Also, if you still attach a regular battery charger to there, that's also still okay. It doesn't interfere with each other. And you can hear a nice photo of someone that's done a really nice, impressive install. Even the conduit is blue, and we always like the bluer the better. So that's a really nice system install there. With a big inverter charger. We have also units, system in a box. So units that are both inverter charger and solar charger. So you have an MPPT built in. So they're called Easy Solar. So Easy Solar come in different variety. So we have ones with all your switch gears, so your circuit breakers, earth leakage device, circuit breakers, so all in one. So the input, the output, and a DC connection. If you want to add a regular solar charger to that, no problem at all. You can, although it has a built-in one, sometimes I quite often get the question, can I add more solar chargers to an Easy Solar, or can I get an Easy Solar with a bigger solar charger? Easy answer, you just add a solar charger of your desired size to the system. It's easy, and you can add multiples here again too. You can put like 10 on there if you want. So that's possible. Then we have the new Easy Solar 2. That one has an MPPT built in, but it does not have the circuit breakers. Quite often, circuit breakers are not quite, see these circuit breakers, not always people, sometimes people even change them because they were not the same as what the local standards demand, or they were not fit for purpose in certain installations. It's beautiful. It's a system in a box. So if you have a really like remote place with not much electricians, there's a lot of Pacific islands like that, Papua New Guinea. These systems are beautiful because you have a safe system instantly, while the regulations might be really slack or non-existent. Here, this is more of a unit you put dedicated in an existing system. You have a proper switchboard. So that's why we decided with this unit to actually have the breakers not in the unit, because this goes into a house install. You can even make an ESS out of a system like this. It has all the required parts for an ESS in already. So therefore we decided not to have the circuit breakers in there anymore. So that's the Easy Solar 2. Same as before, the MPPT and the inverter charger in there, only no circuit breakers. So system with inverters. Well, the last thing, and that's our new inverter smart, that also has an inverter charger split up in two different ways and an MPPT built in. And the really nice thing is we can go all the way up to 400 volts solar. So now we can have a big solar array, and we're starting to get into the grid feed realm now. And yeah, it's a beautiful device. At the moment, we just have inverter only. We will be coming out with an inverter charger version of this. This is a bit our trial. We just do inverter only to just see how good the technology is, how do people like it, do we need to change something before we start building them all as inverter chargers. And so far, the feedback is really positive. It's a lot quieter, it's a lot lighter because it's high frequency. So it's a transformerless unit, a really big reduction in weight. more efficient, especially at standby powers because of less transformer losses. So it's definitely something is being perceived quite well. The ones we've got out in the field already. So if you have a system like this and you do need to charge it because you're off grid, but every now and then you need to charge, you'll need to add an actual charger. And since this is a 48 volt unit, you need a Skylar charger because that's the only one we have in 48 volts. Yeah, but it's really nice. Then and the future will be this. Like now I'm going to talk about adding AC inverters, but if this same presentation is in a year or a year and a half from now, the next part of my presentation will be largely with units like this, the new inverter chargers coming out. So systems with DC and AC solar. At the moment, to get AC solar, you need to get an you have grid feed inverters in there. So you have like Fronius, ABB, SMA, or SolarEdge. They actually communicate with the GX device. If they connect to the same network as the inverter as the GX device does, we can actually read them out via the network. So we know how much they produce in power. But there are a few drawbacks as well. So solar cannot be larger than the multiplus or quattro you use. So if you have this many Fronius or Fronii, I don't know the plural of Fronius, you also need a large amount of inverters because all the power will go through the inverter charger electronics in the inverter charger. So you need to have that the same rating as what's coming in. Otherwise, you eventually blow our units up because it's just built for 3 kVA or 5 or whatever your system is. We always recommend to have a proportion of DC solar at any time in a system like this. The DC solar is needed for black start situations, and black start situation means that if early in the morning, let's say at night, there's no sun coming in, of course, grid feed inverters are off, and then for whatever reason, you've let the battery go down too much. So it's end of the night, batteries are flat, the inverter has stopped, the inverter creates the grid for the AC inverters. The sun comes up in the morning, C inverter wants to work, but sees no grid and is not allowed to turn on. So therefore, it wants to work, but because the batteries are empty, there's no grid for the PV inverter to latch onto. So that's the main reason why, if you had DC in the system, if the sun comes up in the morning, DC will always work. So DC will charge the battery up again, and once the battery is high enough, inverter will charge again, and this happens automatically. And then it starts making grid, and then the big grid feed inverters turn on. So it's important to always have a proportion of DC solar. And be aware that you always need special programming. So you need to tell the inverters, especially in situations where the batteries are full. So as soon as the batteries are full, we need to turn the inverters off, and we do that with a frequency shift. And I've explained about that in my previous webinars as well. So if you don't program the frequency shift in, you will overcharge your batteries eventually, and you will damage the batteries, you damage other DC equipment potentially, can go really wrong. So these are the 3 rules. Not larger, consider DC. Well, we almost recommend DC, I would almost say. Be sometimes too friendly. And special programming. So be aware that if you add DC, that you will always have to do these 3 steps with that. Or use our new inverter chargers, or maybe already the new inverter unit. So we support Fronius, ABB, SMA, SolarEdge. And if that's not supported, then you have to put an energy meter in the system. So you can still then, the GX device can read out via an energy meter how much solar. But we don't use these communications for anything, especially in an off-grid system. We don't use it for anything but to show on our display how much PV is being generated. In an ESS system, we do something, but in an off-grid system, this only for information purposes, not for control and not for doing anything else with. Now, a system with AC and DC solar. So I always recommend to add DC. So this is a beautiful photo I found. There was a Andre from South Africa put that in our work Slack, and I thought just about the time I needed a good photo that showed both, and the day after I thought that he posted that photo. Yeah, it's a really beautiful system. It's got 315Ks in there, but it looks of it, a whole three phase, so three Froni AI, and then a whole pile of DC inverters. And also consider that if your aim of the system is storing energy for night, the energy coming from AC will go through here into the battery. So it gets converted, so from DC to AC and then back to DC. So you have a lot of conversions going into the battery. If it comes from your solar panel, it goes virtually straight away in your battery because this is DC already and it goes to DC. So this is a more efficient conversion, and there's less converting going on. So if your aim is storage, you should really, whatever you want to store, make in DC. And if your aim is use during daylight, then you go from AC straight, yeah, so from DC to AC straight in your house loads. So this part of the system should be in AC, and this part of the system should be in DC theoretically. So that's why in the photo on this slide, they have a lot of Fronius, but also a lot of DC, because this is the best way for that particular system, because this is probably the night proportion of the energy, or the when it's no sunlight, or the winter part of your energy. So that's important to realize. So a good system has probably a combination of both, not just one source of solar. Example of a system like this. So you've got your AC inverter here, you've got your DC here, and basically that's what you can match a generator to that. That's not a problem at all. The generator usually does not run when AC is running, or the generator only runs when the batteries are empty, and then it doesn't matter who charges the battery. So sometimes people are afraid that AC will start feeding into the battery, but into the generator, but that doesn't happen basically because that's when the generator is not on. So that's yeah. Yeah, well, it's like Lego. You just put the right bricks together to make the right type of system. Large off-grid systems. So usually when you have AC, you have multiple inverters. So yeah, you have any given amount together. So the biggest we can do is 180 kVA. That's what our limit is at the moment. So for largest, and if you need bigger than that, then you really need to start splitting things up with groups with separate battery banks. But this is one system, always connects to one battery bank. That's really what we see as a system. Sometimes people ask, do you parallel systems or three-phase system and separate battery banks? Each unit, that's not recommended at all. That's not allowed with our equipment. It needs to be one battery bank. So if you want to go larger, then you need to start splitting things up. You divide the whole site, might be a microgrid or something like that. You say, look, houses, group A, group B, and we have two different systems, two separate systems. Then you can, of course, go as big as you like, 4 systems, 5 systems, etc. But this is really, really big, important rule. Do not underestimate the complexity of a large system. If you want to work your way there, first start with a single system, 1 unit, maybe connect 2 in parallel, small 3-phase system, parallel unit in 3-phase, and build your way up, because this is a science by itself. Just try to calculate at 48 volts DC, what would the currents be with 180 kVA systems? Like, you need to know how to proper size cables, how to put bus bars in, what are the problems with cables. If you put really high current cables in a conduit, for instance, they heat up too much, the cable could melt just because they have a lot of current. You have even cables can start repelling each other because of the current, the magnetic forces around it. So this is really for someone that knows what they're doing. So if you have just started with Victron equipment and then get a quote for 180 kVA system, and you've never installed a multi before, that's not what the type of phone calls we want to get. Yeah, work your way up. And we'd be happy to help you as long as you have got the experience under the belt. Like, that's, can't stress that enough sometimes. But we have, like, if you do land a quote, but you have not quite the expertise, get in touch with your distributor or sales manager. We have a bunch of dedicated systems. The photo I started my presentation off with, it was done by My Energy SA. Serum at My Energy SA is really extremely switched on. He builds really big systems. He can be hired to help you install it, to help you draw it all up, calculate it. So we actually have a number of experienced installers that are available to outsource their knowledge to you. So that's get in touch with your sales manager or with your distributor if you come across a really big system and you don't have the experience for it. But this is how to get experience. Start small and gradually work your way up. So 3-phase systems, what that really is 3 individual units. They all connect to the same battery bank. This is the bus bar system, link system. So these, although they look like individual batteries, they are joined together as a single battery bank. We have big solar chargers here by the looks of it. And then 3 units, and they set up as 3-phase. Highly likely, can't exactly see, there could be parallel, but I think they're 3-phase. That makes more sense. So what happens? You set unit 1 up as phase 1, phase 2, and L3, phase 3. But we require with our 3-phase systems is that the neutral is common. So all the neutrals, so basically you have your AC, your 3-phase supply, phase 1, phase 2, phase 3 goes in, and then the neutrals are all bonded in the middle. So this is what we call a star. So L1, L2, and then neutral here. So this is your star system. We can delta, we can't, our system needs to be set up as a star, but we can supply certain delta loads. But again, you have to have experience with it all, and it is possible, but it's a bit harder. But the Victrons itself always need to have a bonded neutral. And then, yeah, I've got a 3-phase and parallel webinar from the past. So if you want to know more about, watch that webinar and then move yourself up. Guy's got a really good 3-phase training as well on our on Victron Professional on the learning side. So that's look at it. So if you want to add AC solar to it, well, you basically take a big 3-phase solar unit or single ones per, and this looks like there's a 3-phase one and a single phase one. So they have yeah, so it can be, you don't necessarily need to balance things out. Sometimes it's always good to, yeah, it's on average good to have a balanced system. But in some scenarios, it doesn't matter. They might just put solar on one phase, not on all phases. Can be 3 individual solar grid feed inverters, can be a big 3-phase unit, and 3-phase plus a single phase unit as in that example. So yeah, so it's all flexible. It's again like Lego. You just put everything together that needs to be together. Again, the whole thing talks to the color control, so it knows what all the phases are doing. Your display actually changes. It's a bit hard to see on this photo, but you actually get your AC input, and then you get subdivided phase 1, phase 2, phase 3, and also for your loads you get all the 3 phases listed, so you know what's going on. And if you had solar, you also get all your 3 phases of solar listed. So that's it's a nice way of looking at your system. Again, a big 3-phase system with multiple solar chargers, also fine. Can be a variety of batteries. In this case, it's 2-volt cells, can be managed batteries, but the rule is the battery bank needs to be big enough, of course. You can't just have a single battery and hope for the best. Oh yeah, another thing they had here is a bypass switch. And that's an important thing to put in as well. Like, what if something is wrong with one of these units? 3-phase system, or a parallel system. As soon as one unit stops, the whole bank turns off. I mean, the whole array of inverted charges turns off. You still get DC solar, of course, but no more AC. So in that case, you want to put a bypass switch in, that if there's really something wrong with the system, that you have a piece of paper or instructions with the system. In case of troubles, press this switch or pull this lever, and then we bypass the whole system. So your generator connects straight to your loads, bypassing the Victron part. Or if maintenance is needed, you need to do a replacement or something, or you need to work on the system while the rest of the system still needs power. That's another good reason to put a bypass system in, so you can do maintenance, and then the site still has power from the generator temporarily. Parallel systems. In the old days, these occurred often because our biggest unit then was, this is 10 years ago, was a 3K unit, 3 kVA. Now we make 15 kVA units, so there's not really no big need anymore to put units in parallel unless you want to do series parallel, three-phase parallels. And that's the next photo. So now we're taking per string, so each phase, so this is phase 1, phase 2, phase 3 again. Now we have 3 times 15 kVA units times 3 times 3. So you have 9 units, so 9 times 15, etc. So you can calculate how big that's getting. And again, same usually to a bus bar, I hope, because otherwise you have problems. Read my wiring book. Shunt, depends what sort of battery you use, whether you need a shunt. The system, if you have no DC loads, all these quattros together can calculate state of charge quite well without the need for a shunt. Shunt can sometimes be problematic as well in these systems. But this is the battery bank you're looking at. And it's not, you think like, oh, a few batteries. No, that's not that anymore. So you need, and that's why I explained earlier, you need to know what you're doing. That's a big system. That's a very big system. So you need to know about batteries. You need about how to treat them, cooling, air caps, DC distribution, bus bars. It becomes tricky. So that's what you're looking at. And like here, air conditioning in the room, also important. The heat needs system like this, or 2 air conditioners even. I see, plus a extraction fan. So systems like this heat up, so you need to get rid of it. So there's a lot of things you need to know when you make these really big systems. And then really big systems, yeah, basically they become mini and microgrids. These are, yeah, a bunch of houses in a remote location. They all have, there's usually one building with a big solar array that contains the power system. So that's these photos of here inside. Big battery bank, big systems, AC or DC. Here they went all AC. These are all the style DC solar chargers. And then, as you can see, they're erecting already a power pole. They have a bunch of houses or residences around there, and they have a distributed grid. They have power poles, they have AC wiring, like it is in your own neighborhood, but then in a remote location. So, yeah, a big variety of all different type of systems. And you could even theoretically, if you want to do it really fancy, stick PV on all of these little houses around the system as well. That would all work, as long as you set it all up correctly and talk to it correctly. But again, expertise is needed for this. Talking about the batteries. So 2-volt batteries, and 2-volt batteries are still a reasonable choice for lithium. Is nice, of course, and it's got a long lifetime, but a well-appointed 2-volt battery bank still has a really good, yeah, will last for quite long and has a good lifetime. The never build those really big systems with 12-volt AGM and gel batteries. That's not what it's meant for. You need to have proper 2-volt cells and do it properly. But there comes a size and or an application where, or you want a lifetime where you have to start looking at a different technology, and that's quite often lithium batteries or flow batteries. There's even some other type of chemistry batteries out there as well. Because our chargers are extremely flexible, so they have really wide algorithms of charging. So you can, NiCad batteries, Edison batteries. There are so many different type of batteries that you can. We haven't quite met batteries yet. We can't charge yet. So you just make the change the charge settings, and you're there for the battery. But the common thing is the self-managed battery. So these are quite often lithium batteries or flow batteries. So we're looking about BYD, Pylontech, they're the lithium batteries, and Redflow is a flow battery, and many, many more types. We have a whole list on our website, the battery compatibility guide. People will get a copy of this presentation as well with an email, follow-up email. Click on that link, brings you to the guide, and that's a full list. But the most commonly used are Pylontech, BYD, and Redflow in Australia, that is. So just stick with the common ones. But there's many more. So some are not even so self-managed that they don't even need control. So what these batteries quite often do is they generate a state of charge. So they say, I'm 50% full, I'm 80% full. They tell the inverter that, so that's nice. So we don't need to put a shunt in there. There's no need for a battery monitor. We let those batteries decide their own state of charge, and that makes our life easy as Victron. And in some communication is sometimes needed that if the batteries are full, the batteries want to tell the inverter to stop charging or to stop inverting. So that sort of communication happens as well. So that's the BYD batteries. Can be big, can be small. This is a small BYD system. Yeah, that's the new BYD battery changed off a little while ago as well. So some of these slides are still the slightly older battery, but it can be really big. So there's anything in between out there possible. And that's nice, they all communicate to each other. This is actually probably maybe even preferred over a 2-volt cell system, because all these batteries communicate with each other, they all generate state of charge, and it's really nice and easy to manage the whole set. Connecting them is easy. DC connects, of course, to the DC bus. All these, if it's several modules, they all connect to the same DC bus. They come with a battery manager or BMU or BMS, whatever they call it. They come with some block of electronics that has to communicate. So in this case, because it's a BYD, it's called a BMU. The BMU connects with a special CAN bus cable to the color control. And now the color control knows how full the battery is. And it also they can talk to each other. Mainly the BYD talks to us rather than the other way around. But it needs to be done because if battery is flat, we need to stop charge, stop inverting and some other bits and pieces. And it's the same as a normal battery, but self-managed batteries quite often require a color control. For instance, if this cable would be unplugged or the color control is not there, the BYD will not start up. It will need to see, it constantly checks, is color control there? And if not, you have, I don't know how long it is, a minute or 4 minutes or something like that, and then the BYD will stop because the communication has been lost. And it needs to stop because otherwise it will accidentally get discharged too far, something like that. So that's with a managed battery. And this is a BYD, but the Redflow, the Pylontech, they all work in similar ways. They need a communication form, and they need to talk to each other, and they generate state of charge. So this is a Redflow system. I think this was in Thailand. From memory, I'm not sure. And this one here is in Adelaide. That's Simon Hackett's offices. That's basically a backup system. That whole system runs the backup supply for a really big office. So that's a container system. And this is the parking lot. And these are all solar panels. So they give shade to the parking lot. Nice spot to put your solar panels, I would say. Your car stays cool and you generate electricity at the same time. This is a microgrid type system, so heaps of those batteries. Beauty for BYD batteries, it's a bit more environmental friendlier, or a lot more environment friendlier than lead acid. It's a flow battery, and what do I want to say? Oh yeah, it can be discharged all the way to 0, and it's really good with high temperatures. So that there's a lot of specific parameters that other batteries don't have. Lithium batteries are reasonable in warm weather, but hot you have to avoid for lithium as well, but these batteries actually like to be warmer. They do work better, I think, when warm. They even have a heating element in them normally. So if it's warmer, then you don't need to run the heating element so much. They all have special purposes, and they all. But the downside is the red flow needs to be discharged every 2 or something like that days. So multiple red flows is a better way of doing than a single one. Pylon tech, also, but it's pylon tech, yeah. Yeah, this was one of our customers in Spain. The whole system is built in the workshop and then ships out like it is on a big pallet. So this is another way of building your systems. Pre-assemble it in-house, and then you can run through all the testing setup. And when you know it's working properly, then it goes to the site and it gets deployed. So this is another way of building things together. Big Fronius in there. No DC, I see, but yeah, probably some DC somewhere. Yeah, so this is an example. So this is a screenshot from that, the battery compatibility guide. So that list, click on that, click on Pilotech, and you can get these diagrams, how to wire everything together. Yeah. Then backup systems, and that's the last bit. It's basically the same as an off-grid system. Instead of generator, quite often there's the grid. Not always solar needed. Backup systems can do without solar because, let's say if you want to ride out an hour of a blackout, fine. You just have a battery. In the meantime, you use battery, and then when grid is back, you reconnect to the grid and charge your battery again. A boat, a marine system, or a motorhome system, you can almost treat as a backup system as well. So the grid is, the main aim is to have the battery full, not necessarily to make things last. So that's so you can do so without grid, so it can be, it does not necessarily need to be backup for the grid. It can also be backup for a generator. Like picture a big mining site, runs off giant generators. These generators stop working every now and then because they're being the maintenance is done, or they break down, or the fuel runs out. Then also you can have a Victron system backing that up quite easily. Bad or unreliable grid, without grid, load shedding. That's another thing that happens in Africa. And also, I think we were saved by the bell last year, but the year before we had load shedding in Australia even. So that might be a future thing worldwide. Like as it gets hotter, more people use air conditioning. Then when all of a sudden in the middle of the summer, when there's too much load going on, things are being turned off. So that's when backup comes into play. Peak shaving, so you can say every now and then I turn on a really big load, but my AC is only a certain amount. I just temporarily top it up with an inverter until the big load is off, and then I get battery charging again. So you're using the power assist feature of the unit. Power assist. And it can be with or without solar power. So depends. If backup is required a lot of times, then you might as well add solar to it, because then means you ride out bigger periods of no power. If it's only temporary, like this photo for the South Korean Winter Olympics, all the communication was backed up by Victron power. So that's what can happen as well. And that would be just in case. This was probably never used, but you need to have it. You can't just hopefully we don't get a blackout. So certain systems require backup without, and of course you can use UPS devices, but if you need a backup supply for your electric boom gates or your garage doors or something like that, or any big electronic, so you can almost see a Victron device is like a UPS for dirty loads, for big things with electromotors and stuff. So that's UPS quite often for computers. We are for other stuff. This might be the satellite extension mast with electromotors in there and stuff like that. That's where we're good at driving powers with big peak loads and other weird things. Basic backup, no solar at all. So basically, you have the generator or the grid. When that stops, you run off the batteries. If the batteries get low, the system stops. So there is a limit to this, or you can then do other things. In this scenario, when you couple it with a backup generator, so first the grid stops, you'll get power from the battery, and if the battery gets low, then we send a signal to the generator, and then the generator will start and will also recharge the battery and then feed the load. So you can have easily a grid connection and a backup generator and an inverter charger as backup. So first line of defense is your normal inverter charger. Once that runs out because the battery is empty, then you start the generator. So that's possible, for instance. You can add solar. So if the backup is really often, you add some solar panels to it. So you can then ride out longer battery, because while the backup is during daylight, and that's probably, maybe, hopefully still is, you charge your batteries. So while the backup is going on, solar, at least when the backup is during the day, you'll have solar power to power your house loads. So that's and then ESS you can also do some things with, but that's for next week. So Korean Olympics was with a system like that. So this is what they didn't have solar, but you can add solar to that. So that's what that would look like. You can have a backup generator. They probably wouldn't have had at Olympics, but that's possible to add as well. And you can also define the loads. What should run during the blackout? Those are the essential loads, are the important ones, and the non-essential will temporarily be off until the generator or the grid is active again. So that's that way. And then we have one device called the Philex, and we have also a transfer switch, a different type of. But this Philex is an automatic transfer switch that has a priority input and a secondary input. As soon as the priority input falls away, it will immediately switch to the secondary input. And if the secondary input, so it's basically what's in there is like a switch, and the secondary input, when the priority input is back online, then it will switch back to that. So you can basically have a bunch of different scenarios. So you can say grid with backup and inverter charger. So this is grid or generator, and this is the inverter of charger, and that's the automatic transfer switch. So if grid stops, it will go to the inverter. And if, so not even inverter charger, can even be just an inverter, depends. And once grid is back, it will switch automatically back to the original source. You can also actually program a Quattro to do this with some system programming. But in a more scenario where these Philex units are actually being used in more often is to have backup for the backup. So you have your generator or your grid that feeds, that gets split up through two inverters, multis, inverter charges, and that goes to the Philex. The Philex will always connect to the multi-1. Should multi-1 break, then it will connect to multi-2. And then if multi-1 is back online, so maybe someone drives out to site, pulls the broken multi out, put new multi in, or its battery had stopped, could also be possible, remedies the problem. And then as soon as it's back in, the Philex will see that and will switch back to its original source. Could be maybe this one turned off because of overload or something weird, or yeah. So this way it's a backup for the backup. So you can do two scenarios with each unit has its individual battery, or you can connect both units to the same battery. That's also possible. So both connect to the same battery. So this also, if you're talking about backup, this is what's needed. And that's a photo of one in action. I don't even know what system it is. But yeah, it's better be safe than sorry in some situations. AC ignore. So what, and that's another feature I think I've talked about in the last webinars or so, is you can actually treat the whole grid as a backup generator. So you can say, this is always nice and full, like my batteries are full because I've got a bit of solar going on and all sort of other things. So your batteries are full. Now might as well disconnect from the grid as long as my batteries are full. So you can drive this AC input switch its normal feature is to open up when grid has stopped, but now we intentionally disconnect from the grid. So we still leave the normal basic safety feature in place, but we just disconnect from the grid when everything is okay on the red side. I mean on the output side of the multi. So that in that way it's a bit like a really simplistic ESS. So you can build your own proto ESS. I had it at my place long before we even had an ESS. I had half of my house running on something like this with DC solar in there, and then would disconnect unless I run the dishwasher, which the load was bigger, and then it would temporarily connect to allow for dishwashing. And after that, I would disconnect from the grid again. So you can build a really crude ESS system like this, for instance. And yeah, that was the last slide of this webinar, more or less. Yeah, so next week, ESS, but I'll talk about, yeah, so training. Kai is working on a really nice list of training. So these are all the current training segments, and I think there's more coming soon as well. So there are a number of these trainers you can actually use to build systems, and especially the 3-phase one. Where is it? Color control, that is it.
It's down the bottom, I think.
Yeah,
last
here,
one.
these last two. They're good to do, yeah, if you want to go into big systems. They come in different languages now too. They're being translated or have been translated, if I'm correct.
Yep.
Yeah, so that's, yeah, definitely do them and more to follow still. Then we have upcoming events. So yeah, so this is what I explained at the beginning. So if you want to look at past webinars, go to Victron Professional, click on events. That's also how you found this training. Normally you have my events or any events, you have your whole list of events, but now go all the way to the top of the page and it has this little word past event videos. Click on that. And there you get all the recordings of the previous events, also the PowerPoints, a link with, for the PowerPoints as well. So just click on one of them and then you can look at past ones you might have missed or want to see again, that sort of things, or lost my email, anything possible. Then next week, like I said, ESS systems. So similar to today, only talking about ESS, how it hooks together, how to wire it, how to program it. And then the week after, I'm going to talk about some basic troubleshooting, system troubleshooting, warranty, some little bit hints and tips of products. I still have to make that presentation, but ESS is done already, I hope. Yeah, but anyway, so that was it for today. So I'll see you next week, same time. And I'll stop this one, stop share. Yeah, and I'll stop the recording as well.